Hello. In tonight's Unity tutorial, I'm going to go over something that I think is referred to as procedural meshes. It's basically the idea that you make your meshes in code and not in a tool like Blender or in Unity, not making the meshes based off of the primitives like a cube, a sphere, a capsule, you know? So the idea is like the mesh is made from code. And I'm going to go through the simplest mesh, which is a triangle. And then from there, the next simplest mesh from a triangle is a quad. And then after you have a quad, I guess the next thing logically would be to have a series of quads put together in your mesh. And that would be a grid. And then finally a mesh that is 3D in appearance, which is a cube. Okay, so I'm going to go over those things. Hey, cube, fix yourself. There. So I'm going to go over those things starting from right now the triangle. So I made a scene here with a triangle in it. And the simplest mesh that you can make is a mesh that looks like this. It has 3 vertices. 1, 2, 3. All right. So how did we make this mesh in the code? Let's show you. First, let me just press this reset button here, and that should make it face the right way. This is a mesh, and I could actually rotate it in 3D, and it is responding to the light. And as you can see, when I went this way, the mesh only renders on one side. The backface of the mesh is culled. That's called like backface culling. And that's because usually when you make 3D objects, you have like the cube where the inside of the mesh does not have to be rendered. You don't see the inside. So the computer doesn't bother rendering that part, and it only renders one side. So the side that it renders is determined by the order that you specify the points are connected in. So that's why I have these points labeled like 0, 1, and 2, because this is a clockwise, like a clocks go like this in this circle. So a clockwise connection would be 0, 1, and 2, and that makes this side render. But if I put the points in 0, 2, and 1, then the other side of this would render. All right, let's look in the code here. The first thing I needed to do this triangle mesh here was actually just add like an empty game object. All right, let me move this one somewhere else here. And then I have an empty game object right here that I'm going to put at 0, 0, 0, which is right here. And it lines up with our grid that's showing in Unity. And then I'll just name this, this is going to be my procedural mesh object here. And then I kind of created a script for it. Let's see, where's my triangle script? Right here. So if I drag and drop the script onto my empty game object, bam, I get the script, and the script has require components for a mesh filter and a mesh renderer. And if you notice, all the primitive meshes in Unity, when you add them in, like if I added a quad here, there, they have a mesh filter and a mesh renderer. Okay, let me take that out. There, so I add this mesh in here, this empty game object, and then I added my triangle script, and that script added these 2 other components. And I'll show you the script here. Let me click on it. This is my triangle script. Let me close that one. So I'm using the Unity engine, and these 2 lines here require component mesh filter and mesh renderer. They just made sure that the game object had a mesh filter and mesh renderer. If there was no mesh filter or mesh renderer, then it added them to the game object as components, which you saw happened when I drag and drop the script. It added these 2 things. Right now, the mesh filter is set to none. There is no mesh, and then the mesh renderer the mesh render is basically how it's going to render it. So you could specify a material there. So let's just pick this checker material and put it on there. All right, so if I press my buttons here, they're basically more code that I made on my script. What happens is I come in here into my script, and these two make those components. And then let's see what we have here that I'm going to show next is the function get mesh object. No, well, it's all basically this function right here, create mesh triangle. This is the code that will create the mesh object through a script. And the first thing I do is I get the mesh object. So in this function, get mesh object, let's go to the definition. That's right here. I'll expand it. First, I have a mesh variable that I can return, and I set it to null. And then I check to see if Unity is running in the editor or if it's not running in the editor. So application is editor tells me if I'm just running Unity like this. Okay. And if is editor is true, that means Unity is just like this. It's in editor mode. I didn't press play yet. So if I didn't press play yet, I get the shared mesh from the mesh filter object. Okay. But if Unity is running, then I get the mesh from the mesh filter object. So I get that object, the mesh object, right? Now, in certain circumstances, like right here, there is no mesh yet. There's no mesh created. It still equals none. Mesh may equal null. And if it equals null, then I say mesh equals a new mesh object, and then I set the mesh filter mesh to equal this new mesh object. And then I return the mesh object, because the mesh object is, what we're going to play around with. So you would see right here, get mesh object returns a mesh object, whether it has to be a new one or it's one that's there already. And the first thing it does that I do in the script is I call mesh.clear, which will clear all the vertices and all the data of the mesh. So I'm starting off with a blank mesh object. Now, to the mesh object, I set 3 vertices. Those are these 3 points, 1, 0, 1, and 2. C# starts counting from 0. So that's how come I say 0, 0, 1, and 2. And these are the 3 points. So over here, I specified 1, 2, and 3 points. Let's just, I'm going to go back with this mesh triangle. And sorry, guys. I'm just going to reset it. 0, 1, and 2. So I said for me, the user, to specify the 3 points by just making 3 child empty game objects and naming point 0, 1, and 2. That way I could take any of the points here and I could move them around. And then when I press create mesh, it'll use the points that are there, boom, to make the mesh out of where I put the points. Okay, so I figured an easy way to do that when I'm talking in this tutorial is just to make them child of the mesh triangle, to make these 3 points, and boom. But these are basically just empty game objects with a transform position. So point 0, I have it 0, 0, 0. These are all like basically flattened out on the X and the Z plane, this flat plane. So I left the Y component alone. And then the third point, 1, 0, 0. All right. So I get those child objects. This transform is the mesh triangle object. And the transform get child. These of the transform, I have 3 child objects. I have 0, 1, and 2. That's point 0, 1, and 2. So I set my vertices to equal the position. These are vector 3s. And so that's the first step, is set the vertices, the points in 3D space. The second step is I make a triangle, at least one triangle out of 3 points in 3D space. And that's what I did here. The mesh triangles array is an int array, which says the index of vertices. So I say at 0, 1, and 2, I make a triangle. So let's see, vertices, triangle. And then after that, I just said recalculate normals. That's so a normal is a line coming up from the surface of a triangle. It's a line perpendicular to it. And what the normal is used is to determine the light, the angle that the surface is facing, so that, it could figure out how much light to shed on the object based on how it's facing the light. And luckily the mesh object here has a recalculate normals function that does that all for me. So with these two functions, a mesh would be drawn, but it wouldn't be able to put a texture on the mesh. It wouldn't be able to put a material on it. For the material, I need to use the UV. I need to set the UV. So the UV, the number of fields in the UV, has to equal the number of vertices of your mesh. So my mesh has 3 vertices, so my UV will have 3 coordinates. And these coordinates basically take a flat 2D picture. You think of it like that. And I'm saying here that at the first vertice, I'm going to take the picture from 0, 0 over here in the corner. And at the second vertice, I'm going to take the picture from 0, 1. See, so that's 0, 1, that's my second vertice. And then at my third vertice, I'm just going to take the point over here at 1, 0. And basically that's what happened. It just took the picture, like sliced it in half, and drew it on a triangle. Okay, so this is the code here to actually create the simplest mesh. And this code here was the code to get the mesh object from my component here. And what else did I have? I had the reset objects. That's because just like you see here, I played around with some of the points and the angle and everything. And if I just wanted to start over again, I could just press this and have it start from the beginning. And then the update function calls create mesh triangle. So this function is going to run when I run the code. So I'm going to run this. And now with it running, if I play around with the point positions in real time, the mesh is going to reconfigure itself. And that's all I have it in the update function for. So I don't have to keep pressing the button when I have this triangle being created and made. Okay. And it's a mesh, so everything works like if it was a mesh. Can I scale? Well, I have to pick the actual triangle. And then I could scale the whole object up or down. It is an actual mesh. And I could actually make a prefab out of it right there. See? Now it's a prefab. All I gotta do is drag and drop. And there it is. The only thing is the mesh isn't made until I press create mesh triangle. So this is the simplest mesh I can make, one triangle. What happens if I want to make a more complicated mesh? So for that, I'm going to go to my next scene. The next most complicated mesh after one triangle is 2 triangles. So I'm not going to save the changes I did. And this here shows 2 triangles. Okay. So let's see. It's made up of triangles 0, 1, 2, and triangle 4, 3, 4, 5. Okay, so I have 2 triangles. So let's look at the code for this square. I just made an enum here since I had a toggle button right here for the point. So every time I press toggle, it goes through showing all the points, triangle 1's points, and triangle 2's points. Okay, so that's a little bit of a helper code there. And the next thing I have here is the enum to say which toggle thing is set. So it starts off being that it's showing all. That's not really the part that's making the mesh. Here, the function create mesh square is where I actually create my mesh square. So we still got things kind of simple here. So what I did was I made an empty game object that I attached the script to, and the script made a mesh filter and a mesh renderer component. with these two things here and made sure that they're there. And then over here, I just have the 6 points, which let me toggle to show them all. And we toggle show points 1, 2, and 0, 1, and 2. That's point 0, point 1. Let me just do this. Point 0, point 1, and point 2 that are empty game objects that I positioned in the scene. And then it shows points 3, 4, 5. So it's point 3, point 4, point 5 positioned in the scene. Let me show them all. And then after I get the points for the vertices, which here are being specified by these empty game objects in the scene that are children of my mesh, I have to do what? The next step is make the triangles. So what I did was I had vertices for each triangle. So 0, 0.0, 0.1, and 0.2 indexes into the vertices array was the first triangle. And then 3, 4, and 5 is my second triangle. Okay, then I recalculate the normals so that the lighting works right. And then over here, the UV is for the textures. So the first triangle's texture is going to take from, let's see, this is the checker texture here. It's going to take from 0, 0, 0, 1, and 1, 0. Just like the simplest triangle mesh that we had in the last scene. And then the second triangle is going to take from 1, 0, 0, 1, and 1, 1. And as you can see, you put it together and you got this looking like it's coming right out on there. Then I have the same function for get mesh object, which depends on if I'm in edit mode, it uses shared mesh. And if I'm not in edit mode, I actually press play, it gets the mesh object. And then over here, if there is no mesh object, if the mesh object equals none, it's not actually allocated yet, then I just allocate a new mesh object and set the mesh filter to that, and I return the mesh. And over here, the reset objects has to reset all 3 points, all 3 of my child points, and everything's based off of zeros and ones for me for the numbers here. And I also reset the transform and the rotation. And this also has an update, so it could run in update mode. So if I run this, let's see what happens. I'm going to run it and move things around. So I'm going to run it. And here's the procedural mesh, which the update function is continually being called to create this mesh. And, oh, God, I got to move the right thing. Reset. All right, so I pick point 0. And if I move point 0 up and down, you can see that the first triangle of my quad is moving up and down. And the lighting shines appropriately for just the first triangle. And let's see if I pick point 4 over here. This is point 4 is used on the second triangle. If I move that up and down, you can see how the triangle has its own set of points. So point 1 stays there, and this triangle stays here, and this one moves. It brings me to another topic here about the meshes when you make them. The triangles, they could share vertices or they could use their own vertices. So say here, for example, point 1 and point 4 were the same vertex, the same vertice, and this triangle could use it and this triangle could use it. When I'd move that one vertice, they wouldn't separate like this, they'd be together. And the other thing is, other than being together, is that they wouldn't light separately. The lighting calculations for that point would blend together from the two of them. So what does that look like? Let's show that. So here I have my create square mesh. I have the vertices. And for my first triangle, I'm saying use 0, 1, and 2. Let's leave that one alone. For the second triangle, I say use 3, 4, and 5. But say instead of using 4, I use 1. So I'm going to change that code right there. Okay, let me stop the code. Say I use 1 instead of using 4. So let me just save that. Now what will happen is what I'm expecting to happen is that when I move point, oh, what point is that? Let me show the points again. Bam, bam. When I move point 1. Okay, so I'm running. I'm going to pick point 1, and I'm going to move point 1. Both triangles should be affected. You see? Both triangles are affected since it's sharing the point. Yep, that's something, isn't it? All right, so that was the second most difficult mesh, the second simplest mesh. But of course, you know, when we have games, there's more than just two triangles to our meshes. So the next level is to say we now have like a quad and we want to make a plane, like a whole big flat surface, like a land. So we will use something that I do here in the next scene that I have. It's called a grid. Okay, and the grid, I am going, with this one, I do not have any child points to specify. With this one, the whole mesh is created within the script and the points are decided from within the script. And I have a little thing here that I could control the size that the mesh is created in X and Z. Just show you it's being generated procedurally by my script. So let me just put it back to 3 and 3. And then the size of each of these quads is set to 1, a unit of 1. But, you know, I could change that to 2. And it's same thing, the quads are bigger, or 0.5, which is smaller. Bam. So I could control that cell size, put it back to 1. So now let's look at this script here. Here it is, the function that creates the mesh. I called it create mesh grid. All right. So first thing I do is I take this empty game object and I make sure that everything's set to position 0, 0, rotation 0, 0, and scale 1, 1, 1. That's like pressing the reset over here. See, and I set all three of these things back so that the mesh is, the empty game object is aligned on these axes here and at 0, 0, 0. Then I get the mesh object with my getMeshObject function, which we've seen in the other two scenes. You know, depending if it's the editor, I use shared mesh, or if I'm running, I use mesh. Then if the mesh isn't like allocated yet, then I allocate the mesh and return. All right, and then I clear out the mesh, which would basically erase everything you see here. It clears all the vertices, all the things I set. All right, and now I think about how many vertices am I going to have to use to make the mesh, right? So I have to take the size X and the size Z. So if I want a mesh, like I said here, that is 3 by 3, then size X times size Z, 3 times 3 is 9. And then for each quad, for each of these little squares, I have 2 triangles, and each triangle has 3 points, 2 triangles, 3 points, that's 6, times the size X and size 9. And that's how I come up with how many vertices I'm going to need. I'm just calculating it on the fly. Then for the triangles, it's kind of the same calculation. I have 2 triangles per quad and 3 points per triangle times the size X and size Z, since I'm giving each triangle its own points. And then for the UVs matches the count of the vertices. So the elements in the UV has to match the count of the vertices, and that allows Unity to know what do I do with each point that I have, with each vertice. So these are the three arrays that I'm going to mess with in the mesh object. But here what I'm doing, instead of like directly setting the mesh object like I did in Square, see here I got the mesh, I cleared it, I said mesh vertices equals a new array, bam. Here what I'm doing instead is I'm going to create these arrays. These are local variables to this method. These local arrays are vertices, triangles, and UV. And first I set those arrays, and then after I have those arrays set, here I set the mesh vertices to equal my vertices array, triangles to equal my triangles array, and UV equal my UV array. All right. So now let's see. We have the arrays allocated here. They're big enough. Now what I have to do is actually populate the arrays with the actual vertex positions. So just for this flat surface, we have this double loop. So I'm gonna have to go through size X and size Z. So right here is 0, 0. This is the first quad that we're gonna make. So we take, we have to figure out what is our X and what is our X and what is our Z position on in our 3D scene. So I basically take, okay, we're on the first quad. So it starts off at 0 times the size of a cell, which I think I have it here set to 1. So 0 times 1, it's 0. So X is 0 and Z is 0. The first vertex will be right here. So the first quad starts right here. Now I'm going to make the quad. The quad takes 3 and 3 for 1 triangle and 2 triangle, right? So the math here is in my vertices array, this is the offset is like which quad am I in. So I could actually change this to make more sense to say which quad. Okay, so it starts off at quad 0. So the first vertex position is which quad plus basically 0. Okay, and I'm going to say that this point is at X, 0, and Z. 0, 0, 0. This is going to be better shown if I actually run it. So let me just do this. I'm going to put a breakpoint here, and then I'm going to attach this to Unity. Okay, that way when we're stepping through, you can see how the values change. Okay, attach that to Unity. And now let's kick off this function to get called. I'm going to press this button here, Create Mesh Grid. Okay, so here it calls Create Mesh Grid. So like I said, the first thing I make sure everything's reset for the position of my empty game object. Position 0, 0, 0, I want rotation and local scale to be 1, 1, 1. Okay, now I'm going to get my mesh object. And remember, I'm in edit mode right now. So mesh equals get mesh object. So I'm going to step in to the get mesh object function. And right here is the get mesh object. So mesh equals null. And I'm going to see if the application is in the editor is true. So it steps into this here. And we do mesh equals get the mesh component filter shared mesh. All right. And now we have the mesh object, and it's not null, it's actually something. So that means when I get to here about null, it shouldn't be allocating a new mesh. I already have one, and it should just return it. Okay, so that happens just like I said. Now I'm going to have my 3 variables, my 3 arrays. The vertices array, which at first is nothing, but now I'm going to allocate for it. And how many vertices? 54 vertices. So 2 times 3 times 3 times 3. 54 vertices. And the triangles should be 54 triangles. And the UV, it should make an array of 54 of those. Now, if I look at the vertices, they're all set to 0 because nothing is initialized. They're initialized to 0, 0, 0 for the vertices. And for the triangles, let's see. Oops, I didn't mean to do that. For the triangles, oh, what happened? I think I lost my breakpoint. It just ran through. Let me start over again here. Sorry, guys. Am I still running? Yeah, I'm still connected. Press this button again. Bam. And let's just run down to where we were. The triangles, all the values are 0, and the UV, all the vector 2's are 0. So now this job is going to be to set that. So I'm going to go into these. This is a double loop where it's going to go through all the x coordinates and all the z values here. Okay, so x coordinate starts off equaling 0, z coordinate starts off equaling 0. So it's going to be 2 loops inside each, 2 double loops here. And cell is 1 times 0, that's going to be 0, 0. This is the first one that's easy. It's basically everything's going to be 0.000. And let's see the vertices for my first triangle. Let's see now. We got the first triangle. It's 0, 0, 0, 0, 0, 1, and 1, 0, 0. Okay, and then for the second triangle, boom, boom, boom. Second triangle, that starts at 3. 1, 0, 0, 0, 0, 1, and 0, 0, 1. 1, 0, 0, 1. So this is all like very mathematical, kind of complicated. So that's why it's best the computer's doing it in a loop. But as long as I make sense of that I can make one quad, then I can go through this loop and make each one. And I do the same thing with triangles. I have to connect the vertices in a clockwise order. So it's going to go through here. 1, 2, 3. So the first triangle is made up of points 0, 1, and 2. And then guess what the second triangle is going to be made up of? Points 3, 4, 5. So 0, 1, 2, 3, 4, 5. My first quad there. And now the UVs, same thing. I'm going to go through and let's try to get through to the next loop. Run to cursor. Okay, so now x equals 0, z equals 1. Let me get through to another loop so I could have x and z both not equaling 1. So I took off the breakpoint. Anyway, this is the way I was filling in this. And you could do the same thing, break, put a breakpoint in and see the values as they change. And after I got the values, then I set the mesh vertices to equal my local variables. And in the other two, I had shown recalculate normals. That's for the light. Then there's recalculate bounds that sets the size of your whole mesh. So I have all these vertices that I just added to the mesh, to my mesh that I made. So how big is my mesh in the X, Y, and Z axis? So that recalculate bounds does it automatically for you. It gets the extents of your mesh. And then there's another recalculate function, recalculate tangents. And that one basically, let's see, I'm going to show you the definition. Here, there's 3 recalculates. And recalculate tangents, will you show me a little definition? No, it's not showing me, but it does something also for lighting if you use a shader graph. So just for the heck of it, I called all 3 recalculates, Now, this mesh, I did a recalculate bounds on, and I need the bounds for my mesh so that I can make an object that could drop on it and collide with it. So let me just make like a sphere, okay? And I'll just raise it up from there, and I'll just give the sphere a rigid body. Boop. Let's see, physics, rigid body. So it could drop. And now you'll see, since I calculated the bounds on my mesh, and I gave my mesh a mesh collider, when I press play, the sphere will drop with gravity, and it should stop and hit the mesh. So a mesh that I made procedurally, I could add a mesh collider to it, and it could interact in physics in the scene. Okay? So there's one more type of mesh I'm going to show in this tutorial before I make another tutorial, my second one on procedural meshes. But so far, everything we made was flat. It's not really 3D. So the next scene that I have here, my last scene for this tutorial, is that I made a cube mesh. All right. So sitting here, this is not actually a cube. This is just me. I kind of made a demo object here so I could explain my tutorial. And it just has a bunch of quads that kind of put together a cube. So it could help me explain how we make a cube procedurally, because just the way we had to calculate the quads going out in a grid, well, here I calculate just one cube. So the demo object, the way we make the cube, let me just reset. I have sides. Basically, I have a number of quads to make a cube. I have a near and a far. And you can see the near one that's facing me, it renders one side, and the far is facing the other way, so I can't see it unless I'm facing that side. And that's what I meant about the backface is not drawn. The backface is not rendered to save speed, to save time, and that's called backface culling. So the way I controlled like which side renders, remember, is by the order I connect the vertices in. They got to be connected in clockwise order. So I have the near and the far sides. And what I did for that is I just calculated like, okay, this is the near and the far sides. And the points would be like 0, 1, 2, 2, 3, 0. And then on this one, I had the points here. And this image is going to help us when we do the code to know how we connect the points for this cube. Then I also have the left and the right sides and their points. Continuing on from the near and the far, which went up to 7, the left and the right, the next index would be 8. So left and right, and the points for there start from 8. See, 8, 9. It's very hard dealing in 3D. 8, 9, 10, 11, 12, 13, 14, 15. And the last set of sides is the top and the bottom, making 6 sides for a quad. Okay, and those are the points for the top and the bottom. All right, so that's going to help us when we are deciding to make this guy in code. And let me just press clear, and there we go. So we'll take it a step at a time. Let's look at the cube script. So this is going to be my most complicated script in this tutorial, making a cube. So there's 2 types of cubes that could be made here. Remember, this is where I'm really going to see the difference. This cube right now, every quad is using its own set of vertices, so the lighting, kind of looks like that. But if I use shared vertices, then you can see how the lighting gets affected. It kind of blends the corners out, and each corner doesn't get light on its own. Since this is a shared vertice, the light that's hitting this vertice is shared across them all. Same thing as this one, it's dark and it's kind of shared across them all. So that's the difference. If you use shared vertices, you're going to get like smoother looking polygons. And if you use non-shared vertices, here it was just the sides that are shared, then you get more faceted looking polygons. Okay, but I'm going to concentrate on explaining the shared sides one, which is my create mesh 2 function here in this script. Now I have been going through the scripts here, and I haven't actually mentioned where you could get the scripts, so you don't have to type this all in. It's going to be on omrevision.com where you can get the scripts. Okay. Anyway, so here's my cube, my script for my cube to create the cube. And basically, so that I could create the cube at any point in the scene, the function takes in a position, a vector 3 position of where to make the cube in 3D space. And then from that position, which is basically like going to be the center of my cube, this middle point, I just go this way for that. I just offset from the center to make the walls of the cube. So, come on, demo, reset yourself. All right, so the center of the position, okay? That's the center of the cube. That's plus position over here on my vertices for their position. And I'm trying to number everything out. So my vertices, how many vertices will I need to make this cube here is I have 4 vertices per side, because basically I'm going to make the quad share 4 vertices. I'm not going to have 6. I'm going to have 4. I'm not going to make individual ones for each triangle. So there's 4 per side, and there's 6 sides equals 24. So I have 24 vertices. So on the z-axis, I have my near and my far. So that's my z-axis. I have my near and my far, and you see blue is the z-axis. So on my near vertices, I have 4 points, okay? And then on my far vertice, I have 4 points. And the here I just use capital N and capital P to say near on the z. This is the z-axis in the vector. okay? And then I'm just playing around with the X and the Y. I'm playing around with the X and the Y, X and the Y, and Z is near or far, N or P, N or P. Then I do the same thing on the X-axis, so let's take a look at the X-axis. Now on the X-axis, X is left or right. So here on the X-axis, I'm using N for the left and P for the right, and I play around with, what is this? This is Y and Z. I play around with the Y and Z values to make each of the sides here. Okay, and then the last two sides I have are the bottom and the top, and I just play around with the bottom and the tops. While Y stays the same, either top or bottom, this is bottom because it subtracts in negative direction, and this is on the top because it goes forward, and I play around with the X and the Z. So now I kind of make the 24 vertices here, and after that, I'm gonna have my triangles that I'm gonna make. So let's see, there's six per side and 6 sides. 6 per side and 6 sides. So when I have the triangles, here I have 1, 2, 3, 4, but I'm gonna have to specify by, these are the points I'm gonna specify by. So let me just show the far and the near again. And let me show the points. Okay, so if I'm just looking at the near, okay, I have 0, 1, 2, and then clockwise again I have 2, 3, 0. And is that what I did? 0, 1, 2, 2, 3, 0. And then for that's the far triangle. Oh, something's messed up. But I was using this graph to help me. And then the same thing, I just connect the points in a clockwise motion. So if you get some of your points out of order, you'll just notice that you won't see it facing the direction you're expecting it to, and you have to just fix your numbers. These numbers here work for this one that I made over here. All right. So what did I do? I had the vertices, then I made triangles out of the vertices, and then I have the UV so I could actually map a texture onto it. And remember, the UV count has to match the count of vertices. So for every vertex, the UV is basically saying where to get my image in the material to display on that vertex. So I kind of just broke it down here. Now these numbers, where did I get them? So I kind of figured that a cube, it's kind of like a set of dice, and that's why you see me here with the dice. And the dice image here, can I show this? Yeah, can I show it like in a thing? The dice image here, basically what I did is I mapped out the sides are going to show. So if I have an image here that's like a square, and you can get an image like this on, anywhere on Google, you just kind of type for like a dice texture, and then there'll be a bunch of dice images, So, some are mapped this way, some are mapped this way. So the one I picked was kind of mapped like this, you see? Then I just set the colors of each piece so that I could tell which color was mapping where. See, so the near, I have it mapped here, and the far is on the other side, and it's color coded. But here are the UV positions, and then I set the vertices triangle in the UV. That basically makes the mesh, and that will render, and then this makes the UV, this one right here, so I can actually map a texture. I recalculate everything, run the sucker, I get the cube. Whew. Yeah, I hope I explained this to a degree that's helpful. But what I gotta mention is that this is the first procedural tutorial, and I plan to make another one where you could basically walk around a world, or it'll kind of like make a plane, and then when you click on it, it'll make a cube to the mesh there, kind of like a voxel world thing, kind of like a Minecraft-y thing. That's what I plan to do in the next procedural mesh tutorial, but that's going to continue on from this cube thing. So at this tutorial, try it out, play out the different things, play around. Well, you could start by copying the scripts from omarvision.com over here. I'm going to put it on this website, omarvision.com. This is my website. And if you look in the tutorial section, there's going to be this tutorial that I just recorded will be here. It's probably going to be right here in the first position. But if you don't see it in the first position, because I've made 1,000 tutorials since then, you could always just type in procedural and then type search, and it'll find that tutorial for you. So, there you go. I'm pretty sure there's going to get a lot of questions because, well, it's kind of complicated, but not really. You just gotta like think in 3D. It's kind of harder. So you may want to draw things on paper, and that's why I was trying to do these things here with the cube on the side to show like where I'm getting my numbers. Enjoy. Goodbye.